Welcome and hello everyone. So today we're going to learn how to apply the Suvat equations, and from this you should be able to identify which equation you can use to solve the kinematics problems. So let's recap. We have these 5 equations that we have gone through in class. Okay, there's 5 of them, and these are the 5 equations. So there's 5 equations, and if you're given a problem, how do you know which of these equations you can apply to solve that problem? Let's have a look at question number 1. So say we have this, where a car accelerates from 10 meters per second to 30 meters per second, and this occurred in 5 seconds. What is the acceleration? So the best thing to do is, first of all, you have to label the variables that are given. So here it says a car accelerates from 10 meters per second to 30 meters per second. So then we assume that this 10 meters per second is our initial velocity. That becomes our final velocity, and the 5 seconds is the time. And then we're asked to find the acceleration. So what you do is you write down Suvat here. Alright, and you should know S stands for displacement, U initial velocity, V final velocity, A acceleration, and T stands for time. So now let's identify the variables that are given. So here we know U is given, and U is 10 meters per second. And then we have V is given, which is 30 meters per second. And we have time, which is 5 seconds. And we're asked to find the acceleration. Okay? You notice that in any of this equation, displacement was not mentioned. It was not mentioned at all. So that's our clue. Whatever variable is not mentioned, we're going to choose an equation that does not have that variable in it. So here, notice that displacement is not mentioned. So you're going to choose an equation from here that does not have displacement in it. So which one would that be? This one has S in it? No. That has displacement? No. That has displacement? No. That has displacement? No. The first one doesn't have displacement, and so we're going to choose that first one. There's no point solving for displacement and then look for the acceleration. So the best thing to do is find the equation that does not have the variable not mentioned in it. And so we have the first equation. So we're going to use the first equation to solve for acceleration. And so we're going to choose that equation. So to solve for this, V equals to U plus AT. All right, remember we're solving for acceleration, so we're going to make A the subject. So to make A the subject, what do? We remove U, so it becomes V minus U equals to AT. But we want A on its own, so we divide by T. Therefore, acceleration equals to V minus U divided by T. Now you can substitute your values in there. Alright, so it becomes 30 minus 10 divided by 5. So what is 30 minus 10 divided by 5? A equals to 20 divided by 5, and that equals to 4 meters per second squared. So that's your answer. Okay, that's how we use the Suvat equation. So that's example number 1. Let's have a look at the next question. So the next question is this. It says that a skateboarder starts from rest at the top of a ramp and accelerates down the ramp, down it. Now the ramp is 25 meters long, and the skateboarder has a velocity of 12.2 meters per second at the bottom of the ramp. calculate the acceleration of the skateboarder. So this time we're going to look for the acceleration again, but we have some other information that are given. So let's assume that probably the skateboarding is something like this. All right, so this is the top of the ramp and that's the bottom of the ramp. Now it could be this way or it could be that way. Skateboarding. So that's the top and this is the bottom end. So here it says that the skateboarder starts from rest. Rest simply means that our initial velocity equals to 0. So where you see the word rest, note that it means something. So in here, it means that the initial velocity is 0. So probably the human being was standing up there, taking its chance to come down. So at the top of the ramp and then accelerates down the ramp. The ramp is 25 meters long. That gives us the length. So that's the displacement covered. And the skateboarder has a velocity of 12.2 meters per second. So this is now our final velocity. All right. And at the bottom of the ramp, that's the velocity. Calculate the acceleration. So we are asked to find the acceleration. So once again, we write out the Suvat. Let's just rub out this one here, erase that. So let's just have a mental peak of this guy on the skateboard down, and that's the bottom here. So up here we know that u equals to 0 meters per second. Over here we know that v is 12.2 meters per second, and we also know that the length of this ramp is 25 meters. Okay, so we want to calculate the acceleration of the skateboarder while he's on the ramp. And so we write the Suvat again, S-U-V-A-T. This time, displacement given, yes, 25 meters. Initial velocity, yes, because he was at rest. All right, he was at rest, and therefore that's 0 meters per second. We know this is 12.2 meters per second. We don't know the time, but we know that we're asked to find the acceleration. And so from this equation, what variable is not mentioned? All right, we can see here that time is not mentioned right there. So again, we're going to use an equation that doesn't have t in it. So which one is that? That one has t, that has t, that has t, that has t. This equation has no t in it. V squared equals to u squared plus 2as. And therefore, that is the equation we're going to use. And we are going to make a the subject. So we write down the equation we're going to use. V squared equals to u squared plus 2as. This time, we're going to make a the subject. So we're going to transpose to make a the subject. All right. So the best thing to do is you can rewrite the equation, transpose the equation, making a the subject, and then substitute in your values. Okay, so we have v squared equals to u squared plus 2as, and so we're going to minus u squared. So it's v squared minus u squared equals to 2as. Okay, note that 2 times a times displacement, and we're trying to solve for a. So what do? We're going to divide by 2 times displacement, so a can be on its own. Therefore, a equals to v squared minus u squared divided by 2 times displacement, 2s, right here. And now we're going to apply that. So let's see. Substitute in our values, and we'll see what the acceleration would be. So again, a equals to v squared minus u squared over 2s. A equals to, we know that v squared is 12.2, but it says here that we're going to square it, minus 0 squared, and then we'll divide by 2 times the displacement, which is 25 meters. 25 meters. So if you have your calculator, all right, let's punch that in. So we have 12.2 squared equals 2 minus 0. We know that it's 0. And then we're going to divide by 2 times 25 is 50. And therefore our answer will be 2.9768 meters per second squared. We simplify that to two decimal place, not two decimal place, sorry, one decimal place. But then if it's one decimal place, we will round our answer to 3.0 meters per second squared, and that becomes the acceleration of the skateboarder while he is on the ramp. So that is how you use the Suvat equations. Basically, you have to find out the variable not mentioned, and that should give you which equation you're going to choose, and then you transpose to make the variable you're looking for, or the unknown variable, the subject. So let's summarize this. So we have this, look at v equals to u plus 80. We use this equation when we use the first equation when s not given. All right, we use the second equation when a not given. We use the third equation when what variable is missing here? V not given. We use the next equation when u not given, and we use the last equation when t is not given. All right, so this is how you use the equations. All right, makes it easier for you to choose the correct equation when you have the missing variable. So you choose the first equation when the displacement is not mentioned. You choose the second equation when acceleration is not mentioned, and you choose the third equation when v is not mentioned. Likewise for the fourth and the fifth, you are looking for the not mentioned variable, and then you can transpose, make the unknown the subject, and solve this Suvat equation. I hope that helps. Thank you.